All right, sorry about the move, everyone. I think we ought to get started then, just in case this runs long. I expect it's actually going to be a little bit short. Um, so just to make sure that everybody's expectations are at an appropriate level, I don't actually have the answer to get as smooth, as fast as native animations. I know. I wanted to talk about some stuff that we're working on to get there and maybe start a discussion about how we can move forward in this area. Um, So what I wanted to start off by talking about what we can do currently to make things fast. And accelerated CSS animations are a way that you can get things sliding around more quickly. Well, sliding around in a way that you're not subject to main thread jank. The compositor will be busy servicing your animation, and if you run some heavy JavaScript, you won't take that hit. But there's some effects that are tricky to author in this way. I mean, if you have a physics-based effect, some procedural animation, it's tricky to author this way. If you want to do for example, parallax scrolling, that's a little bit tricky to set up with. You can't, right? So there are some effects that that are just not amenable to being expressed in CSS animations. So what about request animation frame? Um, that's a way that you can get a lot of power and a lot of control over your animations. You can do whatever you'd like in your JavaScript callback. But unfortunately, you are subject to main thread jank if you do some very expensive operation, and you can hit currently some unexpected costs on your main thread. You might not get your animation may not be as serviced as frequently as you would like, and you get hiccups in your animation that are quite unfortunate. Um, so the ideal situation that we'd all like to be in is that we'd like to drive our animation from a thread that's clean. And what I mean by clean is that you're not subject to unexpected jank, that you have some control over the work that happens on that thread. There's no surprises, basically. Um, and having the ability to control it from JavaScript is nice as well because you can be quite expressive there, but it's not as much a requirement. You really need to have the ability to clean up a thread or have some control over the work that's happening on the thread. Um, but which thread should that be? Um, Ideally, it would be the main thread, and there's been a lot of discussion already at BlinkOn about cleaning up the main thread. Um, I mean, the biggest and best thing we can do to get some of the work off the main thread is to find those inefficient things that we're doing by accident and move them off, right? So those things that we're doing wrong, where we're taking performance hit, we should find and get rid of. And Elliot mentioned a great number of them in his rendering talk, which is excellent. So we should find all of those and squish them. But if we did squish them, what are other things that we can do to make the main thread more amenable to running animations? Well, a theme that's been seems to be running through this conference was to give authors control over the performance characteristics of their page. And some suggestions that have been thrown around very informally that might give people that kind of control are things like overflow clip, which Tab mentioned people are on board with this morning, which is awesome. And what overflow clip would do is it would let you mitigate layout explosions, right? You can sort of contain the layout problem to discrete portions of your page, so you won't take that massive layout hit by accident in ways that you weren't expecting. Something that I'd heard yesterday, and I won't speak to because I don't understand it very well, is manual mode, where you, if you decided to, would assume control over the operation of your page. So if you were to, for example, change the width of an element, you would have to manually say, I would like to repaint this. At the time, that would be appropriate to repaint it. So basically giving the developer complete control over the performance characteristics of their page. And partial layout would be another way that you could do that. And in this way, the web author can incur the cost of expensive operations when they choose to, and can decide not to incur those costs while they're doing something that's performance critical, like an animation. So there's a lot to say on this area. And in fact, I think this is crucial to talk about, and I'd like to bring the conversation back here at the end of the talk, but I'm going to leave it for the moment to suggest an approach to dealing with, and this is really a mitigation for currently dealing with a main thread that's not yet jank-free. What about doing some work on a web worker? I mean, that would be great. I mean, it could potentially be free. It's not held up by main thread jank. But the problem is you couldn't muck with style on a web worker, right? What if you could? I mean, there's some things that would obviously be awful to do from a web worker. If you, say, mucked with a property that forced a layout, say, or caused a big style recalc, that's untenable, right? You have to jump over to the main thread and deal with the consequences of what you've done there. So that's just a no-go. But I've been thinking, or more fairly, Rob Kroger at the Waterloo office had an idea that maybe we could identify a set of properties that don't incur this cost, that don't require that you go to the main thread and pay the layout and style recalc price. You bundle them up in an object that we're calling the animation proxy, and you can operate with them perhaps on another thread, not necessarily. There are a number of benefits to doing it this way. Let's see if I can go over here. Well, one of the benefits is that it's pretty expressive. One thing that would be really nice is if we could, implement accelerated CSS in terms of this. It'd be kind of wonderful if you could pull that out of Blink, out of the compositor, and just implement it on top of this. Smooth scrolling is something. So that was one of. I should have spoken to this earlier. The properties that are layout free that we've currently got are transform and opacity. Most vendors can accelerate, so things that you can have accelerated CSS animations for. Most vendors make those fast. Also, scroll offset, we can often update that on the impl thread without incurring main thread cost. We're hoping to add more to this list, right? Some other properties that are like gimmies for this are animating, say, background color or sliding around background position. Those things feel like they ought to be acceleratable, but aren't yet. But so this set of layout-free properties hopefully will expand a little bit. All right. So moving on from there. So scroll offset was one of those things that we're hoping would be layout-free. And if you could, then you could animate it, say, on a worker thread, and then you could implement smooth scrolling yourself in JavaScript, which would be kind of nice. You could do things like sniff your scroll position as well. So if you're doing a long scroll without actually listening to events, you could know that you're about 80% of the way to the document. You want to post a message to the main thread saying you might want to generate more content and throw it up. Parallax is also quite simple because you can, listen to your scroll offset and do something with a parallax layer that's behind you and slide it a little bit more slowly. Lots more. So it's pretty expressive. I worry that that's too small to read. Is that too small for everyone to read? Yeah. I'm just going to skip this for now. The slides are posted. If you'd like to take a look, this is an example that I've whipped up to show how you might use element proxy to achieve parallax. There's actually a link to an explainer document that has a bit more surrounding context to this, so I would encourage you to look at that. But I'm going to skip that for now because it's not going to be very useful for people to read. This is how I'd expect it would really look in practice, though. You'd probably say, hey, fancy library, I'd like to parallax scroll on a scroller with this image at this rate. And what I mean by that is I think the primary consumers of this animation proxy thing will probably be library writers, and people will interact with it through some library that does the pushing of stuff over to a worker thread for you and moving things around. And you can be quite creative with how you author this library, which is kind of nice. How will it work? I'm not 100% sure how it's going to work, but I'm going to wave my hands a little bit and attempt an explanation. It's going to work largely the same way that we implement accelerated CSS animations. But with accelerated CSS animations, and Doug, please correct me if I'm getting this wrong. Is Doug here? Right here, right. We run the animation. We don't service it at the same rate. And in fact, I think we avoid servicing it at all possible on the main thread. Right? We can run the animation on both the main thread and we run it on the compositor thread, right? So we don't actually have to push any information back from the compositor thread to the main thread because it's able to interpolate its own values if it needs it. But for impl scrolling, we do this. So if we're, say, updating our scroll offset on the impl thread, when we do a commit, we also plumb back all of the scroll offsets, the scroll deltas, actually, that we've applied on the impl thread that the main thread doesn't know about. We plumb that information back. In the same way, if in a web worker we request a couple of transform updates, those get applied to the compositor thread, but the main thread hasn't found out about those updates to these properties. In the same way, we're going to have to plumb that back to the main thread. And that means that the main thread is going to have a slightly out-of-date idea of what's going on in the same way that the main thread has a slightly out of date idea of what's going on with CSS animations. But that seems to work in that case, and I expect it would work in this case as well. I'm happy to answer more questions about, like, technical questions about this, but I'm going to sort of dodge the specifics for the moment and just move on to the drawbacks to the approach, and there are a couple of big ones. One of them is that more threads is quite painful. I mean, on phones, we haven't got many cores, and we're already really getting bit pretty hard by threads. But I'm hoping that the idea might still be useful even in a world where we don't have very many cores. Even if we're not able to run this in parallel, it's at least it lets things be preemptible. So even if you have a very, very long running main thread task, you at least get serviced at some rate on the other thread instead of blocking until the very end. Another thing that I like about it is that if you animate in terms with an animation proxy, we've only exposed those properties that are guaranteed to be fast. That is, you can't hit performance cliffs when you interact with it, and that's one of the, it's sort of foolproof in that way. You're not going to accidentally muck with an animation proxy and get one of those unexpected paint storms, say, or an unexpected layout storm. Another worry is that we might be committing to implementation details here when we expose a kernel. We don't want to sort of pin ourselves down to an implementation that's going to be a hard thing to work with in the future. But my thought on this was that accelerated CSS animations exist currently, and I think they're going to continue to exist for the foreseeable future. And what animation proxy, I think, really is a JavaScript hook into that existing functionality. So if we're going to have to make accelerated CSS animations fast, in the same way, I think we can continue to make this fast. So I think the two are quite tied together. It's just sort of an imperative hook into that existing functionality. So my hope is that we're not actually marrying ourselves to the implementation details here. Another idea that's been discussed, albeit very roughly and with lots of contention, was the notion of dealing with events on one of these workers. So if you, say, created a proxy and said, I would like to listen to events that relate to this on the worker thread, that the worker thread would get a chance to consume some version of these events, probably not an event that you could prevent default on, but although this is all very controversial and not pinned down, but it could perhaps get an event that it could gesture recognize on, but not cancel. And in that way, you might be able to implement a gesture recognizer in your web worker and do animations over there in that way. I've got a little bit more information in an explainer up there. So if you're interested in reading a bit more detail, feel free to go and visit that. I'd also like to mention another idea that I've heard discussed recently to move some work off to a worker thread, and it's the Canvas and Workers idea, where you would allow rendering to canvases in a worker thread, and you could share a rendering context between multiple canvases, and that way you could do OpenGL-y sort of dimensional things on another thread. And there's, again, a lot more information available for it on the WhatWG site there. But I'd like to bring the conversation back to the main thread. I'm curious what people think is preventing us. Like, what are current barriers that you can think of that would make it impossible for that currently make it impossible to use the main thread as that clean thread that you do animations on? Especially if you think that thing is something that we might be able to fix. So I was going to, that I think is the end of the discussion. So at this point, feel free to ask me questions about anything that I've said, or if you've got ideas about things that we might tackle to clean up the main thread, that would be great to talk about now too. This is something that I don't know a ton about. Nat, would you feel comfortable chatting about it a bit?
I mean, I'm paraphrasing Greg Simon too, who's also been throwing this around. So we talk a lot about, oh, layout bit me, or oh, we had a paint storm, or load event came in. So on Safari, iOS, they have a way to put the thread into a mode where certain events don't hit the main thread. They can just say, don't accept network in, like just hold it. And 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 when you do DirectX, you decide when to call draw, right? When you just try to get into GL and you're like, oh, I don't want to draw, so I won't, right? We have RAF, so manual mode is something where you start just saying, yeah, what if I could say don't do this, or I could disable certain things, or on the other extreme, you tell me that a recalc style is needed, and I will call it, and if I don't, then that is my fault. I just shot myself in the face, but I got a nice idle thread and as a result. Some other things floating around in this front are freezing elements, being able to say element.freeze, and then if you mutate its width, it will change size, but the stuff inside it won't, so it might stretch. There's a lot of crazy stuff there. Who knows if that's good for the web? Probably not, but it would be not janky.
Thanks. Ken. I think it would. I think that's a fantastic idea. I'll ask Brian about that. I think that's quite reasonable to pursue. Hey.
When I write for iOS or I write for Android, there's some amount of predictability when I make a call as for how long it's going to take. With the web, it's not really that way, is it? I mean, there's this really awesome map from Paul Irish. I don't know if he's around that shows. Sorry, I'm not focused on the front. I'm looking at the lights in the back. Anyway, um, which is basically all red, right? And it sort of reminds me of if you've ever programmed against the V8 API. Anytime you call into the V8 API, you could collect. You have zero control over it, right? Thank goodness we have incremental collection there now, so it isn't a big deal. But this is a real problem with the web. Like you can't. There's no predictability of it, or very 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 little. And so no matter how many Stack Overflow articles that you read, they're not always going to be helpful, right? So this is something that we need to work on and fix to make the web more palatable for folks. I mean, it's really awesome that I can write a web page by just throwing text at it, but often the honeymoon ends very fast. Anyway, Rick.
Along those lines.
So it's open mic.
Along those lines, I just came from EdgeConf in New York, and one of the panels they had there was dealing with third-party scripts. And I like it's so easy, I think, for me on the Chrome team to think of like, here's the website, and there's a web developer. But like everybody there was like, there was people from media companies, and they were talking about how like they embed ads from other companies, they embed Facebook like buttons from other companies, and then there was like the Discuss guy there was saying, I build this stuff that gets embedded in other people's pages, and I get like the New York Times calling me saying, hey, you're janking my page, and all this fighting between all these different people. Like in this world. If we dejank the main thread and we do our job perfectly, how do we solve this problem that there's multiple competing organizations all competing for the main thread? And how can any one of them ever have a smooth animation when, they're different companies with different incentives? Yeah, I mean, if they can move to iframes, that would be great. But they're not even iframes today, right? Like, how do you make like a Discuss thing an iframe when it can expand and, animation proxy would solve that, right?
So one thing I'm curious about is like what Greg's talking about trying to make operations more predictable, and what Ian's talking about trying to dejank the main thread are sort of two sides of the same coin in some sense, right? And so there were some ideas earlier, like manual mode, like the overflow clip thing, that would be steps towards making operations more predictable, and maybe if we just had enough of that, that would be kind of sufficient. But I guess what I'm wondering is if people see other sources of jank on the main thread that we don't have ways to kind of limit, right? Like we can, like we're talking most of those ideas surround providing more developer control over style resolution and relayout, and presumably from there painting validation.
Mhm.
But there's other stuff going on. I don't know. I don't have a complete enough picture to say. I'm curious for thoughts.
That was a great way of articulating it. By dejanking, what I meant was removing those unexpected hiccups, right? It's not that I was suggesting we take all work and push it off the main thread, just giving control over when it happens and how it happens so that it doesn't accidentally happen when you don't expect it. And it's true, I think we need to identify those unexpected ones and really flag them and see if we can make them more predictable or give ways to make it more predictable.
One way of making it more noticeable is, I know there's like Android. Sorry, it's just Android has this strict mode that you can turn on, and whenever you do something on your main thread, like I/O, your screen flashes a red border around it to say don't do that. You can turn that on. Brad Fitz did it in Android, and so I think we can probably do something either in Blink or in Chrome to say these things that we think are bad on the main thread. Anytime they come up, we just flash a red border around the screen or something.
I mean, this could even be a DevTools feature.
Yeah.
It doesn't need to be standardized or anything, right?
Sure. I wouldn't think we would standardize it, but just as something like
You wouldn't run in this fast mode production.
The user would turn it on.
It's just diagnostic mode to make sure that you're not doing naughty things when you weren't expecting to do naughty things, right?
Exactly.
Right. It's a great point.
Okay, Nat asked me to show a few things because he's been talking about this sort of thing, and I did a talk about it last week. So I'm just going to real quick show just a few slides from that. Okay, so this I've gotten a few questions about kind of the operation. So this is the DevTools timeline. And people ask kind of what are the operations that I should see and kind of what order. And this in general is the flow of recalc style layout, paint, compositing. This works and in an animation loop, each of these things has a cost, but really it depends on what we're animating. So with transform and opacity, of course, really we can just throw it all to the GPU. In some cases, on desktop, we have to promote with the translate Z hack, and so we do that. But we can keep it really, really fast. Throw it to the GPU, forget about it, main thread's clear. A lot of other things need to get a paint. So every single change to one of these properties, on every single frame, it'll have to do the rasterization. So box shadow, background, outline. Outline's kind of like border, but border does affect the layout, so outline's kind of free in that way. Whereas there's a lot of CSS that does affect the geometry of the page, and so it incurs a layout. Tom and Nat and I spoke with a team. I was working on Google Search. They were using some cool animation transitions and basically trying to animate the sides of a box as they were bringing in new content. Of course, it was basically animating max height, min height, one of those. And so, of course, the content beneath it was shifting down during that animation. They're trying to, do this smoothly, but because we incur layout, paint, and compositing layers on every single frame, it looked terrible, especially on low-end devices. And so, basically, the more work that we have to do, especially in an animation loop, the more it's going to suck. So this is, I think, Nat showed this yesterday, and this is, so on the Chrome status, we published the popularity of different well, we publish like trend lines, but this is the popularity of all CSS that's found on the web, at least by Blink's CSS parser. And so a lot is indeed the layout of the page. And so we do, for any changes to these things, we do require layout, paint, and probably compositing. But potentially there's room here to identify ways that we can avoid doing layout. I think there's actually a few open bugs where things that we should only have to paint, maybe even visibility, do currently incur layout costs as well. And yeah, so Nat said something like this before. There's 4 things that a browser can transition jank-free currently: scaling, moving, rotating, and fading, which translate in CSS land into these things. Sometimes with layer promotion, not however with keyframe animations, as Ian said. So that's nice. But whenever, so I showed this to developers last week, and so that's kind of my message to developers. And I wish that it was possible to do other things more than these 4, but these are the things that are currently fast.
Awesome. Thank you very much.
So this is what we make our developers do now, and that's why I wanted Paul to show, because that's what we're asking every one of our people who want to fake an Android look or an iOS look. That's what they got to memorize, that table and then it doesn't work, and then we change it because we're evergreen, and then it changes out from under them. Like this has got to be better. It's just cray. But I'm done.
We are actively trying to make it better. Like I was saying, background color, right, and background position. There are a number. So we have a very similar list to the one that you had, which is it measures the ones that we animate most frequently, and thankfully we see transform and opacity right near the top. So by and large, people are doing the right thing, which is awesome, right? But we have a bunch that are really close, like left and top, which are like heartbreakingly expensive, and you wouldn't expect it. And in some cases, if it's not actually changing the width of things, we might be able to make those quick, right? So it seems like there's a lot of low-hanging fruit there. If we look at and I wish I had the slide ready for you, ill-prepared. But some of those that are very close to the top are very amenable to acceleration. So I think we can make the world a lot nicer than it is currently. Great, I think, is there another comment or question over here? Yes.
So there was a talk on the web animations yesterday and the web animations JS API. I just want to know how that relates to the animation proxy API, which seems to be layered on top of the same stuff and serve a similar purpose, especially if it can be used on the main thread as well as in a worker. Is this just solving the same thing twice, or am I missing something here?
So the animation proxy thing, it just exposes a number of properties. It's really a kernel that you would build a rich API on top of. It is not that rich API. Web animations provides a lot more functionality than this does. This is just getters and setters for properties that we know are quick. That's all that it is.
You could imagine implementing at least large portions of the web animation spec on top of this, though.
Yep. Yeah, and I would love to implement a lot of the accelerated CSS stuff on top of this kernel as well. Like, it seems like a bunch of stuff could be built on it. Yeah.
But again, if we had a primitive like this, then you can sort of let the frameworks flourish, right? And we don't need to build everything into the platform because you just let jQuery do it. And great. But I don't know if this is the right direction to go. Saying there's one upside.
All right, if there's no more questions, then I think I'm going to call it. Thank you very much, everyone.